we see this symbol, which is called the greatest integer function. So this denotes the greatest integer function, which means the largest integer that is less than or equal to x. So this says let f of x equal the greatest integer function with cosine x, and we're going to look from negative pi to pi, and we're going to sketch the graph and then look for these limits. So let's first of all just graph a cosine graph between negative pi and pi, so we can think about what that looks like, and then we can think about the greatest integer function of that. So we're going to start with negative pi, and we'll go to pi, and at negative pi over 2 and pi over 2, we know that the cosine of negative pi is negative 1, and then of negative pi halves is 0, then it goes up to 1, and then back to 0, and then down to negative 1. So this is what our graph of just cosine x looks like between negative pi and pi. So if we wanted to sketch a graph, we'll put it down here, of the greatest integer function. We first of all see that at negative pi the cosine is negative 1. So at negative pi we are going to start down here at negative 1. Now as we move along to negative pi halves, we see that the cosine is something between negative 1 and 0, but it's not yet to 0, and so the cosine x value is not yet to 0, so the greatest integer for any of these values here would be negative 1, because it's the largest integer that is less than or equal to the cosine x value. So that's going to stay down here at negative 1 until we hit pi over 2, but at pi over 2 the cosine is 0, and so that's going to be open here and it's going to jump here to 0. Now as we compute that, then as we look at cosine values between negative pi over 2 and 0, we see that they are positive, but they are fractions less than 1. So they haven't yet reached the next integer, which is 1, so we have to go back to the other integer, which is 0. So they're going to be staying along here at 0. And then at x equals 0, the cosine value is 1. So that's going to hop up here to 1. But immediately it now drops to a number less than 1. This is a number between 1 and 0, any of these cosine values in here. Well, because they haven't reached 1, the greatest integer, the largest integer that is less than or equal to things like a half and so forth, would be back down at 0. So we're back down here at 0, and when we get to pi over 2, it equals 0. But then as we go to the right of pi over 2, the cosine value is going to become negative, and it's negative some fraction, like negative square root 3 over 2, negative 1/2, and so forth. And so the greatest integer that is less than these would be negative 1. So this is going to hop back down here to negative 1, and it's going to stay on that until we reach pi. Now that we have our graph, we're ready to do the next part of this, which says evaluate each limit if it exists. So we're interested in the limit as x approaches 0. So as we're looking here to approach 0, if we approach from the left-hand side or the right-hand side, we see that we approach 0. Again, it doesn't matter where the function value is at this point, it matters what value we are approaching as we get closer and closer and closer to x equals 0. So the answer to this is 0. The limit as x approaches pi over 2 from the left-hand side. So here's pi over 2. We can see as we approach that from the left-hand side, we are approaching a function value of 0. Let's look at part 3, the limit as x approaches pi over 2 from the right-hand side. So as we're approaching pi over 2, as we're approaching from the right-hand side, we're down here, and even though it's not defined at pi over 2, as we get closer and closer to pi over 2, we are at a function value of negative 1. And the fourth one, the limit as x approaches pi over 2. Well, the left-hand limit was 0, the right-hand limit was negative 1, and they don't agree, so this does not exist. Let's look at part C. For what values of a does the limit as x approaches a of this function exist? So as we're looking here, the only place we have issues is at negative pi over 2, the left-hand limit doesn't agree with the right-hand limit, and at pi over 2, the left-hand doesn't agree with the right-hand. At all other places, from negative pi halves to pi halves, they agree, and so the limit exists. So I'm going to go ahead and list this as an interval. And so if we have from negative pi to negative pi over 2, the limit exists. And then also if we have from negative pi over 2 to pi over 2, because anything in here, the limit exists. We saw it at 0 that the left-hand limit still agreed with the right-hand limit, so we were okay there. And then our last interval would be from pi over 2 to pi. Now, as I'm thinking about the two endpoints, negative pi and pi, I included those because it gave us a domain up here, and so that was for all points in the domain. But they're actually one-sided limits. This is just a right-hand limit, and this is just a left-hand limit because of the endpoints.